Hi guys, welcome to this tutorial where we're going to be introducing many of the Blender modifiers that are used to edit our objects within the 3D viewport. Keep an eye on the links in the video description as we're going to be introducing each of these modifiers in this video, but at the same time each of these modifiers is going to have its own unique video that you can watch if you want to go into more detail with regards to that modifier and tool. Modifiers can very quickly change the shape and form of an object without having to go into edit mode. To access your modifiers, come over to the Properties panel and then select the Modifiers tab. It will look like a wrench. Left click and you should see the Add Modifier button. Left click again to bring up a main menu. You can search for a specific modifier. You can add a Geometry Nodes modifier, which will allow you to create your objects using nodes in the Geometry Nodes workspace. Alternatively, you can choose from one of these additional menus. For this class, we're going to be focused on the Generate menu, as this will primarily impact the geometry of our model. If we want to add one of these to our object, simply select them from this list. For example, we can select the Bevel Modifier, and this will adjust our entire mesh based on the parameters of the modifier. We can add multiple modifiers at the same time. Currently, we have a single modifier, which is the bevel. We can go to Add Modifier, Generate, and then add a second one, such as Subdivision Surface. We can add a third one, such as Wireframe. Here we're able to add as many modifiers as we require for our objects, and every time we do, we are able to stack the effects on top of each other. The order of our modifiers is going to change the final result of our model. Currently, the Bevel Modifier is being added first, so we are adding bevels around the object. Then we are creating new geometry with the Subdivision Surface modifier. After that, we take that new geometry and we create a wireframe from it. But let's say I want to swap the Subdivision Surface with the Bevel modifier. I can simply click and drag my subdivision box and move it up and down. Let's move it to the top and see what happens to the cube. It now becomes more spherical. The Subdivision Surface modifier has this sort of effect on a cube, where it adds geometry and makes it more spherical. So it defines this new shape before we add the Bevel modifier. Then, after the Bevel modifier, we use the wireframe. Let's see what happens if we take the wireframe and stick it above the bevel. Again, we get a new final result. The wireframe has been added first after the subdivision. So we have the base shape and then that geometry has been transferred to a wireframe. If we zoom in, the Bevel modifier is then used on the wireframe itself. If I increase this segments parameter, for example, you should see we're adding more segments to each of the different areas of the wireframe. In summary, the modifier stack is just as important to editing your objects as the modifiers used themselves. Each modifier has its own set of parameters. However, it also has a set of tools that are visible on all modifiers. First of all, I want to make note of the ability to remove our modifier with this X button. Just left click and we can remove the wireframe modifier. As shown in the previous part of the video, this icon here allows us to click and drag the positioning of our individual modifiers. Again, I can use the X button to remove the bevel. If you take a look in the top corner, you'll see a down arrow. You can left click and that will minimize the selected modifier. This is useful in case you have multiple modifiers that you want to add to the modifier stack, but you're only ever working on one or two of them at a time. If you take a look, we also have the ability to rename the instances of each modifier. So here, I can just change this to any name I want, for example, divide. I can add multiple versions of the same modifier. So I can come down to Subdivision Surface, left click, and now we are actually subdividing our mesh 2 times using 2 different modifiers. If I close up the parameters of our Subdivision Surface modifier, you'll see we have additional icons. The first icon is the cage modifier, so it will allow us to adjust the editing cage. If we left click at the moment, we're not seeing anything within object mode. If I go into edit mode, you should see the original shape of our model. This is how it looked before we added the Subdivision Surface modifier, and we are still able to manipulate this geometry. However, whenever we manipulate the geometry in edit mode, the Subdivision Surface modifier will adjust in real time. If I was to click on this cage option, then the modifier actually takes a more exact effect on the model. In edit mode, we can no longer see the original shape. So the original shape is now being projected in the same way that the modifier is. We can still select and edit our geometry as we see fit. It's just a different way of viewing our model while working in edit mode. The next option is the ability to display the modifier in edit mode itself. If I toggle this off, then the object just looks normal, as if the modifier was never added. But if I return to object mode, you can see we still do have the modifier affecting the model. The final 2 options determine the visibility of our modifier. The first one here that looks like a monitor determines if we can see our modifier's effect in the 3D viewport. So whereas the option before allowed us to toggle its display in edit mode specifically, the real-time option allows us to determine whether or not we can see the modifier at all, regardless of the mode we are using. The final option here, which looks like a camera, will determine whether or not you want that modifier to be displayed when rendered. This is particularly useful when you are creating preview renders of your model and you want to see the final effect of specific modifiers in your stack. If we take a look at this down arrow here, it can open up a new menu. We have a few options here, such as the ability to duplicate the current modifier. This will duplicate the exact settings as well. So if I was to delete this, increase the number of levels in the viewport to 3, and then duplicate, you would see the parameters are exactly the same for the additional modifier. We also have the ability to pin, so this would keep the modifier at the end of the list. What that would do is if we were to pin, we would see the icon here, and if we begin to add some modifiers, then we would be able to add those modifiers on top of the subdivision surface, but you can see it's always at the bottom. For now, let's toggle that off and remove the 2 modifiers that we just created. We have the ability to move to first and move to last, so we can reorder using this menu. Again, I'm just going to add 1 modifier, and we're going to use the move to last option, and that will move the subdivision surface to the final slot on the modifier stack. Alternatively, we can move to first for the opposite effect. Finally, we have the apply option. Currently, what we see here in our 3D viewport is the effect that the modifier has on our object, and when we render with the current settings, that will take into account the modifier's parameters when we render our object. However, if you were to export your model, then you may want to apply any modifiers that you have. If we return to edit mode, you can see that we still have the basic shape of the cube. Now I'm going to go to apply, but it's grayed out. We can't apply our modifiers in edit mode, we can only do so in object mode. So come back and apply the modifier. The modifier itself disappears from the properties panel. If we go into edit mode, you can now see that all of the geometry generated by that modifier has been permanently applied to our object, and we can now edit that geometry as normal in edit mode. Let's now start working our way down the modifier stack, starting with the array modifier. The array modifier acts as an ability to duplicate your original model quickly and effectively across multiple axes. We can determine things such as the fit type. By default, this is set to fixed count, but we can have it fit a specific length or even have it fit a curve object. We can increase or decrease the count value, which we can use to determine the number of instances of our original model. This actually includes the original model itself. So if we were to set the count to 2, we would have the original model plus a single duplicate. By default, we use relative offset. This means that we use an offset value that is determined by the size or dimensions of the current model. When it is set to 1 on the x-axis, we have both of our objects being pushed together. If we increase this above 1, we can create a space on the x-axis. We can also change the values on the y and z axes if we want to determine exactly the direction that the array is going to travel. If you don't want to use relative offset, you can instead use constant offset. This uses the Blender units that are defined in your unit settings. So if we go to our scene settings here, we can go to units and we can define the unit system and the unit scale as well as the length parameters. These are what are used with the constant offset. So currently we have it set to a single meter, but we can use an exact distance by manipulating the x, y, and z values here. We also have the ability to determine it by an object offset, so we can use another object to determine the direction of our array. I'm going to choose the camera for this example, and you can see that the object offset has it rotated and repositioned where the camera is. If I increase the count, then this change of rotation and location continues to be affected for each additional count in the array. The next modifier that we have is the Bevel Modifier. This allows us to create a bevel across all of the edges on our model. We can define whether or not we want to bevel the edges or the vertices themselves. Most of the time, you want to choose the edges option. We can determine the width type, which changes the way the amount parameter underneath will work. For example, I can set this to 0.2. This will increase the distance of the bevel. Currently, we're using the offset method for the amounts calculation, but if I change this to width, you can see that the actual width of the bevel has changed. I can choose depth, percent, or an absolute value. Remember, each of these width types is going to change exactly what this value means. Below that, we have segments. By having a single segment, we effectively take an edge and we divide it into two edges either side. The distance between those edges is then determined by the amount parameter. Every time we add a new segment, we add an additional edge to the bevel. The more edges we have, the more geometry we have, but the smoother the bevel is going to appear. Depending on the object you're looking to create, will change the number of segments that might be suitable for that model. For beginners, I recommend anywhere between 8 to 10 segments for your beveled objects, and then apply smooth shading to get a good look at how the modifier affects the object. Below that, we have the limit method, which by default is set to angle, but we can set this to none, weight, or vertex group. If you set it to angle, then we can adjust this angle limiter, and that will change which edges are going to be affected by the bevel modifier. This is a bit difficult to show on a cube, so I'm going to replace the cube with a UV sphere. We're going to add the bevel modifier, and now let's decrease, first of all, the angle of the limit method. You can see once we go low enough that more and more of the edges begin to be affected by our bevel modifier. As we increase this value, it reaches a point where none of the edges are being affected by the modifier at this point. Up next, we have the Boolean Modifier. The Boolean Modifier allows us to cut into or combine objects depending on secondary target objects. If we take a look, we have three options: intersect, union, and difference. We can change the operand type, which by default is set to object, but we can also use an entire collection. We can determine which object is going to be the target for the Boolean, and the solver or the calculation that is used. Exact is an option that takes longer, but is more accurate. Fast is, as the name implies, a very quick result, but depending on the complexity of the objects used in the Boolean, might result in a few errors. To best display this, I'm going to add another object. Let's add a cylinder. I'm going to scale the cylinder down on the X and Y axes. So I'm going to use the C plane to reduce the size and then bring it up on the Z axis. This is what's going to be used, and actually I'm going to just scale it on the X as well. Doesn't need to be anything specific, but I'm going to take my original object, which is the cube, and I'm going to set the object target to the cylinder. Now it doesn't look as though anything is happening here, but what we are doing is we are using the cylinder to cut a hole into our cube. If I was to apply this Boolean modifier, and then I was to hide my cylinder object, you can see how the cylinder has cut into our cube object and created new geometry. Now I'm going to bring the cylinder back into view and hit Ctrl Z a few times to bring back the Boolean. The next option is union, and this is going to combine the two objects together. Now the target object is still going to exist, but it's going to create sort of like a duplicate of that model, and then it's going to add that duplicated geometry to our existing model. If I was to apply the Boolean modifier again, I can move the cylinder, and what we're left with is the cube object, but with what looks like the cylinder poking out. So this is where we have taken the geometry of the cylinder and added it to the geometry of our cube object. Again, I'm going to use Ctrl Z a few times until we get our Boolean modifier, and the final option here is for the intersect. This is going to, with the target object, maintain the geometry that is being intersected with the target. So in this case, the only part of the cube object that is going to be kept is going to be the area of the cube that is intersecting or overlapping with our target cylinder. If I was to go and apply this, I can hide the cylinder model, and this is all that's left of our cube. The build modifier is used to construct an object based on its geometry over time. You can set a start frame and a total length. Now, if we was to play our model, you can see over time each of the edges and faces being constructed. This is more noticeable if we use an object that has more geometry. So I'm going to replace our cube object with a UV sphere and add the build modifier. Now, keeping the start frame and length the same, we're going to press play to play the animation, and you can see how the geometry is constructed over a period of 100 frames. If we want this to take longer, we can increase the total length. For example, let's set this to 240. Then press play, and you can see that the build effect is much slower. Now, one way in which you can use this is you can play the animation using the build modifier and then determine the point in the animation that you want to say, okay, this is the shape that I want. So for example, we can set it to 90, and then we can apply the build modifier. This is going to apply the modifier's effect on the geometry at that specific frame. If we move back to frame 1, you can see that the geometry hasn't been restored or deleted. So the modifier is no longer in effect because it's been applied, and this is the new result for our geometry. To go back, just press Ctrl Z a few times to bring back the build modifier. By the way, we have the randomized option as well as the reversed option. So we can set the reversed option so that all of our geometry is present at the first frame. We can then press play, and this time the geometry will disappear instead of appear in our 3D viewport. Alternatively, we can use the randomize option. Now, combined with the reversed tick, we can press play, and you can see a very different effect on our model when it comes to which of our faces are being removed. The Decimate Modifier is the modifier version of the Delete and Dissolve tools. For this example, we're going to use the UV sphere again because it has more geometry. Locate the Decimate Modifier from the Generate list, and you should see 3 settings at the top: Collapse, Unsubdivide, and Planar. These are the methods used for dissolving or deleting the geometry of the model. At the bottom, you can see the current face count. Now, when we have it set to collapse and a ratio value of 1, no geometry is being deleted. As we click and drag to reduce the ratio, watch the face count value. You should see that it gets lower and lower. Eventually, you'll see this on the model itself, as a lot of the geometry begins to merge together to form new faces. If we set this all the way down to 0, we end up with a face count of 2. So make sure not to go too low with this ratio. We also have options for the unsubdivide and planar. Unsubdivide allows us to effectively use something similar to the unsubdivide tool in edit mode. You can increase the number of iterations to rapidly decrease the face count, whilst also maintaining the general direction of those faces and edges. If you go with an iteration value that is an odd number, you may get a sort of cross effect where the geometry begins to spiral. This is also true if we go to a higher value like 3, although we have less geometry to work with in this case. Then we have the planar option. This determines the effect of the Decimate modifier based on the angle limit set here and also the delimit option. So we can define things such as the materials used on our object to determine where the Decimate modifier is being effective. If we reduce the angle limit value, this is the same as basically turning it off. But as we increase the angle limit, more and more of our geometry is going to be decimated using this method. Again, keep an eye at the bottom of this Modifiers tab to view the current face count for your object. Edge split allows us to divide up our geometry along its edges. Go to Add Modifier, then Generate, and select Edge Split from the list. This is a very simple modifier that will divide up our geometry determined by the edge angle and whether or not we're using sharp edges. Currently, we have it set to 30 degrees. If I was to apply this modifier and go into edit mode, I can select my geometry and press the G key to reposition. You can see that we have been able to split this geometry. So now we are able to manipulate it as if there are 2 edges and 2 vertices in the same location. The mask modifier has different use cases, but its primary use case for me is to act as a way of hiding a selection of my model so that I can edit other areas more easily. Here I've got a cube that has been subdivided, so it has some extra geometry. I want to take this top face and I want to add it to a vertex group, so each of the 4 corners of this face is going to be added to a vertex group. To do this, I'm going to come down to Data in the Properties panel and click on the plus button here to add a new vertex group. Then I'm going to rename this as Top and click Assign. This is important because we're now going to add our mask modifier. We can choose to mask geometry based on the vertex group or an armature, which is effectively a rig. Vertex group is quicker, so we're going to display that in this video. Define a vertex group in this area here. We've created one labeled as top. While we're in edit mode, we can't see anything, but if we enable these 2 options here, you should now see that we only have the first top face visible. These are the vertices that were added to our vertex group. Alternatively, we can click on this option right here to invert this effect. Now, any of the faces that were connected to the vertices of our vertex group are made invisible, and we can begin to edit the remainder of our object. The mirror modifier allows us to duplicate an object's geometry along one line of symmetry or more. In this example, I'm going to take the cube object and I'm going to create a loop cut down the center. We'll create one along the y-axis and the x-axis, and then what we'll do is we'll take half of this object and delete it. So I'm going to go into my wireframe viewport shading, and this will allow me to use box select to highlight the appropriate geometry, and then I'm going to delete these vertices. Then I'm going to return to object mode and solid view, add modifier, generate, mirror. We can see that we have been able to mirror the object's geometry along the x-axis. We can also change to the y or z axes, but the effect will be determined based on where you have cut your model. In this example, we have cut using the x-axis. So what I can now do is I can now take some of the geometry on my model and manipulate it on one side, and you should see that the effect is mirrored on the opposite side of that axis. So I can move this along the x-axis, for example, then up along the Z to create a new shape on both sides. Multi-resolution is perhaps the most complex modifier that we'll be looking at in this video, but we're just going to cover the surface level of what it can do. Multi-resolution is effectively a more controlled way of subdividing your mesh. Add the multi-resolution modifier to your object, and by default it will have no effect on the model. You have three values here: the level of the viewport, the level when sculpting, and the level for the render. At the moment, we've not actually added any subdivisions to the model, so when we attempt to manipulate these values, they are all fixed at 0. Let's now use this subdivide button here. This will add a new level of subdivision. You can see that the levels for the viewport, sculpting, and render have all increased by 1. The idea here is that we can add levels of subdivision from this button right here. We can then increase the total number of subdivisions that we can make using this modifier. So if we subdivide a second time, all of these increase to 2. However, now we have the ability to manipulate these values between the 0 to 2 range. For example, we could set it so that when working on our object in the viewport, we have the number of subdivisions set to 0. When working with sculpting and sculpt mode, which can be accessed here, we see an increase in geometry. So when working in sculpt mode, we can determine how much geometry we want to see here when manipulating our model. And then of course the render is going to be the final result. We can also have different types of subdivision, such as simple subdivision and linear subdivision. The Remesh modifier is used to take a much more geometrically dense object and create a less dense version. Here we have an object that has a fair bit of geometry, but not enough to warrant using the Remesh modifier. We're going to use Ctrl and 5 on our keyboard. This will add the subdivision surface modifier with 5 levels of subdivision. I'm then going to apply this modifier, so we now have a lot of geometry to work with. I'm going to go to Add Modifier, Generate, and Remesh. From here, we are able to reconstruct our model depending on the method of the remesh and the chosen parameters. We have voxel, sharp, smooth, and blocks. Each of these has its own set of parameters, which you can manipulate to get a final result that is closer to the original model. With blocks, for example, we can determine things such as the scale, and keep in mind that some of these values may be quite slow to change because they have such a significant effect on the object. So if we type in 0.7, reducing the scale increases the size of the blocks, reducing the geometry. The octree depth allows us to maintain the finer details. So 4 is quite a low level, but if we set this up to 6 and press enter, we start to get something that looks more like the original object. If we go to 8, we get an even closer approximation of the model. Each of these different methods allows us to manipulate the new geometry of our model in a certain way. It should also be noted that each of these has the option for smooth shading at the bottom. So for example, we can go back to blocks and have it set to smooth shading if we want that kind of effect on our model. The screw modifier allows us to take a very small amount of geometry and spin it on an axis to create new, more complex shapes. For this example, I'm going to add a cylinder, go into edit mode, and I'm going to select 2 vertices. Then I'm going to use Ctrl and I to invert my selection, press the X key, and delete my selected vertices. This should leave us with a single edge. Now I'm going to go to my Modifier Stack, and add a screw modifier. This allows us to create new geometry that rotates around a axis point. In this case, it's going to be the object origin along the z-axis. We can define the total angle of the screw modifier, and this will determine how far around the axis we're going to orbit or rotate. We can define a screw value which repositions the end point of the geometry up and down along a specific axis, in this case the z-axis. And we can also increase the number of iterations, so the number of times these other parameters are going to be applied to the model. So here we can further increase the number of iterations to bring the geometry up and continuously loop around our axis point. We can define the number of steps for the viewport and the render. This effectively means how much geometry is added using the modifier. If I reduce this down to 4, you can see the significant drop-off in geometry. Opening up the bottom area where we have the normals, we can turn off the checkbox for smooth shading to get a more accurate representation of the geometry that's being generated. We can increase the viewport steps, and you'll see in real time the geometry that is added as we increase this number. The skin modifier allows us to wrap new geometry around just a few edges and vertices to create a more complex model. Here I have those edges and vertices sort of shaped like a human. Now this is an extremely basic example, but we've effectively created this geometry on a single axis and then used the mirror modifier to mirror it over the y-axis. Next, we're going to go into object mode, add modifier, and add the skin modifier. This is going to add new geometry in the form of new edges, faces, and vertices that will surround the existing part of the object, which were the edges and vertices that we had previously. I can toggle off the display in the 3D viewport, and this is what we had before. This is what we get after with the skin modifier. We can use tools such as branch smoothing, and that will allow us to compress the new geometry in areas where the vertices are relatively close together, such as the neck area and at the bottom of the torso. We can define things such as the symmetry, but this will change depending on the direction or the way in which the geometry is facing. So in our example, using X symmetry is actually perfect for what we want. We can use smooth shading as well, and this is going to apply smooth shading to the generated geometry through the skin modifier. You also have the ability to create an armature. So this is a great way of creating very simple character models very quickly, and then adding an armature to which you can then rig that model. If you want access to these other options, which we're not going to cover in this video, all you have to do is go into edit mode. So the skin modifier is one of those modifiers that is primarily used in both object mode and edit mode, while most other modifiers are typically used in object mode alone. The Solidify Modifier adds thickness to our models. With something like our cube here, we're not actually going to be able to see the effectiveness of the Solidify Modifier because it's a closed model. So to best demonstrate, we're going to go into edit mode, go face select, and delete the top face. Now we can see both inside and outside of the object. Currently it's infinitely thin, which isn't going to be good for applications such as 3D printing. To add our thickness, we're going to add the modifier, go to generate and select solidify. You might have noticed that some additional geometry has been added. In the modifiers tab, we can change the mode. So currently it's set to simple, but we can go to a complex operation as well if we need to. We can also determine the thickness, which is the main parameter for this modifier. So as we increase the thickness, we're increasing the effective distance between the inside and outside of our object's geometry. We can manipulate the offset value underneath. So with it set to -1, the thickness, when increased, is going to push the geometry inwards towards the center of the model. But if we were to reverse this to a positive value of 1 and increase the thickness, then the geometry is going to be pushed out. This will actually maintain the volume inside of our box object and increase the thickness, which in turn will increase the size of the model. We can change the way this offset is calculated by enabling the even thickness option, and this simply changes what the thickness value refers to. So here we've got 0.3 meters, and having it not set to even thickness is going to measure it via one method. So for example, from the inside point to the outside point in a straight line. Or if we go with even thickness, it might relate to the corners, so the distance from one corner to the next. Subdivision surface allows us to add new geometry very quickly. Add your subdivision surface modifier to the modifier stack, and you can see the additional geometry immediately added to the model. In the properties panel, we have two main options: the levels for the viewport and for the render. The greater this value, the more geometry is added around the entirety of our object. Be careful not to go too high with your viewport level. Depending on your computer, Blender may start to slow down, lag, or even crash if the viewport level is set too high. When it comes to the level, you can only toggle as high as 6. This though is going to be more than sufficient, and you can see from a simple cube we've now generated a sphere that has hundreds if not thousands of little tiny faces used to construct it. So you really don't need to go beyond a value of 6. In fact, most of the time you'll probably only need to go as high as 4 for your levels in the viewport, and then you may want to go a little bit higher for the render, which is the result of the modifier when rendering your objects as an image or animation. The Triangulate modifier simply allows us to convert all of the faces on our model into triangles. Here we have a Suzanne object with a lot of four-sided faces. I'm going to add Generate and then choose Triangulate. You will see on the model that many of these faces have been converted so that now they are split into smaller triangles, which actually better mimics what you would see in a game engine. In game engines, we work with objects that use triangles rather than quads or n-gons. This helps for different rendering techniques within the game engine, so you can use the Triangulate modifier to preview how your object might appear to a game engine, and you can come over here to manipulate things like the quad method, which basically changes the way in which the four-sided faces are going to be converted into triangles. Across the board, your four-sided faces are going to be converted no matter what, but the way and the direction in which these triangles form is going to change based on your option here. So just go whichever looks best. The quad method relates to all four-sided faces, but the n-gon method relates to any face that has more than 4 sides. We have two options here, beauty and clip, but they're not going to show much on this model because it's a default model that typically only uses triangles and four-sided faces. Finally, the minimum vertices count allows us to determine which polygons or which faces are going to be affected depending on the number of vertices that they have. By setting it to 4, we allow for all face types, including quads, to be converted into triangles. If we set this up to 5, then all n-gons, which effectively means any face that has 5 or more sides, will be affected by this modifier. The higher we go, the more vertices a specific face is going to require for it to be affected by the Triangulate modifier. The Volume to Mesh modifier requires 2 objects. It requires the mesh object in which the modifier is going to be applied to, and the volume object which the mesh is going to be added to. In this example, I've created a volume, and then I use another object, Suzanne, to act as the target for the mesh to volume modifier. This is not the same as the volume to mesh modifier. I've done this to create the basic shape that you see here, and I have hidden Suzanne herself from view. Now I want to take my cube and I want this geometry to be applied to this volume. To do that, I can go to Add, Generate, and choose Volume to Mesh. The mesh is going to disappear, so go to where it says Object, left click, and choose the volume. Left click, and now that geometry has been added to our volume, and it has effectively created a mesh based on that volume. The Weld modifier allows us to take 2 parts of the same object and effectively bring the geometry together so that there are no spaces between. Here we have a cube object, but we actually have 2 cubes, and you can see they are currently disconnected. We're going to add our Weld modifier. The key parameter here is the distance. Increase the distance value until you see that the 2 objects merge together. Now we have used the Weld modifier to create a single coherent object instead of 2 separate pieces. The Wireframe Modifier allows us to very quickly convert any mesh object into a wireframe. Go to Add Modifier, Generate, and choose the final option, which is Wireframe. As soon as you do that, the entire model is going to be converted into a wireframe that has thickness based on all of the edges and vertices used to construct the original model. We can define the thickness of the wireframe using the first parameter. We can also define the offset, which is the direction in which the geometry is generated. So, is the geometry going to push out, making the object larger, or is it going to be pushed in? We also have other ways in which we can manipulate our wireframe. For example, by default, we have the Replace Original option ticked. If we untick, then we effectively create the wireframe and add it on top of our existing geometry. We can also determine how the thickness value up here is calculated by defining whether or not we want an even thickness or a relative thickness or both. Thanks for watching, guys. If you're interested in learning more, then check out the links in the video description for access to our exclusive course library.